Hello guys, in this session we're going to learn how do we use the Qsort built-in function available in C language to sort the elements. We will be demonstrating how do we sort integers, strings, as well as how do we sort structures based on various fields. Let's begin the program by trying to sort simple integers. So I've just taken a list of integers here, right? There are some duplications, like 12 is duplicated. That's perfectly allowed. I'm calculating the number of elements with the help of size of operator, right? Here I just need to write size of numbers will give me total memory allocate for the entire block and what is size of each element. And once if I get this, I just need to use Qsort, right? Now, in order to know how many argument does Qsort take and all, you can just go to the prompt, right? I'll just increase the font size. Just write man Qsort. If you look at Qsort, it takes 4 arguments. The first argument is the base address of an array. Second one is the number of elements. Third one is the size of each element. And the fourth one is a comparison function, right? Okay, the first 3 should not be any problem. To pass the base address, we'll just write the array name. It will pass with the base address. What is the second one? Number of elements. Third is the size of each element. What is the number of elements? N. What is size of each element? It is an integer, right? Okay. Now coming to the last one, comparison function. Remember here, if you can observe, it's a function pointer, meaning we are supposed to write a function which follows this particular interface, right? And we need to pass that function name. When you pass on the function name, the address of the function will be passed. Now what should that function do? You can just read here. The comparison function must return an integer, right? So return type of this comparison function is integer. It should return an integer value which is less than, equal to, or greater than 0 if the first argument is considered to be respectively less than, equal to, or greater than second. Meaning, given 2 values, if the first one is lesser when compared to second one, it should return a negative value. If both are equal, it should return 0. And if the first one is greater when compared to second, it should return a positive value, right? So you should just write a comparison function, but it should follow this particular interface. This should take 2 arguments of const void star and return type should be integer, right? So let me just try to write a comparison function. The name of the function can be anything. This name can be anything. It need not be only this one. Okay, let me just try to use meaningful name, right? Okay, it should take const void star. Okay, const void star, right? Now remember, these are void pointers, so we cannot even directly dereference. Okay, so if you want, you can typecast it to an integer pointer. I'll just typecast it. Okay, I'll just try to use const int star. Okay, p1, right? I'll just write pa. Typecasting from void to a generic to a specific type. We don't really require any typecasting explicitly in C, but we do require this typecasting in case if you're working with Turbo C or C++ compiler. Now, see, you can dereference the value, okay, the pointers and get the values. You should return less than if the first one is lesser. If we should return equal to, if it is both the numbers are equal, you should return positive if the first one is greater. In order to perform this, you can just dereference the pointers and then perform the subtraction. Remember, assume that the first one is 12 and second one 32. First one is lesser. What is 12 minus 32? Minus 20, negative. Now let us say it is 32 and 12. 32 by, okay, is greater when compared to 12. Then what happens? Okay, if you just perform this operation, it will be plus 20, right? So this statement is sufficient. Okay, and this typecasting, because we cannot directly dereference a void pointer. Fine, just pass on this compare int. Okay, and then you can just try to print the elements. Numbers of I, and once we print everything, we'll just try to print a new line here. Fine. Okay, in order to use Qsort, please make sure that you include this stdlib.h. Even this, okay, if you can just see the man page, you can get to know that we require stdlib.h. Right? So we have done this code. Let's try to compile and let's try to execute this. Okay, we'd like to write gcc. I'll just write sort.c. This is the file name what I've given. Right? Sorting perfectly fine. Okay. If you want to sort in descending order, you know what you should do? You should just come down here, P2 minus P1. That's it. Do this, compile it, execute it. Done. Any problems here? No problems. Okay. Now this what we did is for integers. Now let us try to do with strings. In order to work with strings, I'll just take some names, right? So now, okay, each name assuming that there are 20 characters upper limit, and let me just try to write some names. You can take up any names of your choice, any number of elements, right? If you want, you can calculate. If you're commenting this, then you can also use n itself there. If you're not commenting it, okay, then you have to use a different name there. Fine. So right, I'll just write it as m, and something very similar to this. Okay, number of elements is size of names. Okay, divided by each name is of 20 characters. Each name is of 20 characters. Okay, so you can hard code is 20, or okay, if you want to say, if I change this, even this should change. So we can just write size of names of 0, like each element, right? So in this case, what happens is if I change it to 30, this will automatically give me 30, right? Okay, I think I'll use 20 itself. It should not be a problem. Okay, fine. Now I'd like to use Qsort names m. Each name is of 20 characters. Now you have to use compare function. So I'll just try to write one more comparison function, and again for the printing part, I'll just try to take up this. And how many elements? M number of elements. Each one is a string. Let me try to print a new line after everything, right? It is stored in names. Now I would like to write a comparison function which can compare the strings, right? So let me just take up the copy of this. Okay, I'll just try to say this is str. Then this part remains the same. Only thing is you can use character star. And then if in order to compare the strings, you can just take the help of built-in string library function like string compare, right? And string compare will automatically take care like character pointers comparison, and that anyhow returns 0. Okay, in case the strings are equal, it returns positive value. The first one is greater when compared to second, so it matches with this. So you can just use this, right? And then I want to sort. Which name do you think will be the first name? There are two names starting with A, right? So it's going to sort based on the alphabetical order. Okay, since you have two names starting with A, then you need to check out the second character R and S, right? Okay, so based on R and S, whichever comes first, alphabetical order, that will come first. So let us try to run this. Just try to compile this, right? Quite a simple one. Clear? Okay, so no complications at all here, right? Quite a simple. We were able to sort strings, we were able to sort integers. Any complications? Now, okay, let me just keep these functions down because this is not something what we want to observe now. Let us try to work with structures. Okay, so this is not required for me. You can take up any structure, let us say student, right? I would preferably use type def here because I don't want to write struct every time. Okay, underscore t will be quite good in this name because it's a type defined name, right? I just write based on ID, based on, let us say, character name, right? Each name is of 20 characters, and let us say marks. Fine. And I'd like to create an array of student records. Student will be the data type, right? And as I said, like underscore t will really be a good practice because it's type defined name. Then you can just write student, just okay, or you can say records, right? Each one has ID, name, and the marks, right? So let me consider this is the first record, this is my second record, this is my third record. Okay, this way you can just enter the details, then we will try to sort this. This is my third record and this is my fourth record here, and then the value could be some value here, okay, and then the final record. Some value. Fine. Okay, sorted, done. Okay, and then I don't want remaining code and all, so I'll try to do one thing. I'll just rename this as n. Okay, and remember this is an array of records, so I just need to put an array here. How many elements are there? You can just write size of records divided by size of each record. We can just write size of student underscore t, right? Okay, or records of 0, that's fine. Here we need to pass records and let this be n. This will be like whatever the size of student. Okay, so we'll just try to take this. Now comparison function, what you need to write should match up with the same interface, and inside the comparison function you can specify you want to sort based on the marks, based on the name, based on the ID. So I'll just write, okay, let us say compare string itself, or okay, and here I'd like to print %d, %s, %d, and then records of I dot, what is the first one? Records of I dot name, records of I dot marks. Fine, there are n number of elements. Okay, I want to remove these things which is not required. Okay, if you want you can retain this. Now I want to compare based on various things. I'll just come back, take this again. You want to sort based on which field, right? So this is based on, let us say, marks, right? Now this is a structure. Okay, this is a structure. Now when you have this structure, you need to access based on which field? Based on marks, right? Based on marks you want to compare. Done. Okay, so we'll just say compare marks. Fine. Okay, now after this, okay, if you want you can just verify this, and later on if you want you can just do it based on the name also, right? This is the program what we have. This structure, okay, a simple comparison one, right? And then call the Qsort, print the records. Fine, let's try to compile this. No problems at all. It is sorting based on names in ascending order. Yeah, if you want you can also sort in descending order. Now you want to sort based on the names, so you can just I'll just not change the function and everything. I'll just write name. Okay, I'll just let this be there. I'll just say return string compare based on the name, right? P1 of name, P2 of name. Done. Okay, see, I have not written a separate one to say it is based on the name and all. I've just changed this code because this is a major code, right? Okay, so I'll just try to sort it. Done, guys. Quite a simple one. So now onwards, whenever you feel that there is a need for you to sort either integers or a strings or a structure, don't write your own sorting, right? You can just take the help of Qsort. And in order to use Qsort, you don't really need to know the algorithm of Qsort, right? So that when you talk about Qsort, you have this partitioning techniques, divide and conquers method and all those things, right? Okay, so you really don't need to study all those things. Okay, but whenever you try to implement your own sorting, generally you end up into bubble sort, which is not a very efficient one. Quicksort is much more efficient when compared to bubble sort. Always use the built-in Qsort one. Thank you.